Now, linear magnification produced by lens. What is linear magnification? It is ratio of size of image to that of size of object. Suppose this is a lens. This is the principal axis. This is an object AB. If you take this ray which is passing through optical center, it will go undeviated, and this is focus. So this ray will go undeviated. Take one ray that is parallel to principal axis. After refraction, it will pass through focus, and these two rays meet at this point. So this point is point of image, or image is formed here. Let this is A prime, B prime. This point be F. This point be C. So this is our ray diagram. Now, if you see triangle ABC and C A prime B prime, these two triangles are similar triangle. Triangle ABC and triangle A prime B prime C are similar triangle. Similar triangle. So in case of similar triangle, a ratio of corresponding sides are equal. So A prime B prime upon AB, we can write A prime B prime upon AB is equal to C A prime upon C A. C A prime upon C A. This we can write. Now this distance is said to be object distance, and it is negative, and this distance is said to be image distance, and that is positive, you know. Now if I put this as size of image, it is, you know, below principal axis. So to measure size of image, you have to go below principal axis. For this region, you have to take sign negative. So I am putting here minus I, because length I is measured going below principal axis. This is size of object, and you have to measure object size going above principal axis. So if you measuring length above principal axis, that is positive. Let its size be O, is equal to C A prime. C A prime is V, and this is positive. C A is U, and that is negative. So this negative cancel. And so we can write I size of image upon size of object is equal to V over U, and this is, by definition, this is called magnification. Magnification. It is ratio of size of image to that of size of object. So M is size of image upon size of object. This is from definition, and this is what we derived. So if you compare this equation with this equation, we can write at this place M. So M is V over U. So this is magnification, and this is called transverse magnification or lateral magnification. Transverse magnification or lateral magnification. So I am writing it MT, transverse magnification. Transverse or lateral magnification. In transverse or lateral magnification, we measure length of image or length of object perpendicular to principal axis, either above principal axis or below principal axis. So this is formula for magnification. Now this formula can be written in some other form also, 1 upon V minus 1 upon U is 1 upon F, and here U is negative, so this become positive. If you take 1 upon V on this side, so it is 1 upon U is equal to 1 upon F minus 1 upon V. Now if you multiply by V, so it is V upon U is equal to V upon F minus 1, and this is magnification. So M is V minus F upon F. This is another way to write magnification, and here you have to take sign of M. If image is inverted, then this is negative. If image is erect, then it is positive. So whenever you are going to use this formula, you have to take sign of M. You may write it like this also: 1 upon V plus 1 upon U is 1 upon F. I am writing this step because U is negative, so this negative become positive. If I move 1 upon U on this side, so it is 1 upon F minus 1 upon U. If I multiply U, so U upon V, U upon F minus 1. Take LCM, it is U minus F upon F, reciprocated V over U is F over U minus F, and this is M. So magnification is F upon U minus F. Here too you have to take sign of M. I have taken sign of U, but you have to take sign of M whenever you use this formula. So magnification, lateral or transverse magnification, we have learned 3 expressions. Remember these 3 expressions. First, M is V by U, and this is valid for both convex lens as well as concave lens. Second, it is F upon U minus F. Third, it is V minus F upon F. So these are the 3 expressions of transverse magnification. Important formula, remember the formula. Now what is longitudinal magnification or axial magnification? In axial magnification, we put object like this and we measure length of object, length of image along principal axis. So if object and image lies along principal axis, then we define longitudinal magnification or axial magnification. Longitudinal or axial magnification. Suppose this is a lens and length of object is like this. So this is length of object and here it is du. Suppose image is like this, its length is dv. Then what is dv over du? This we have to find. Longitudinal magnification M subscript L is ratio of length of image along principal axis to that of length of image along principal axis, length of object along principal axis. This is the definition. So let us see how it comes. We know 1 upon v minus 1 upon u is 1 upon f. If I differentiate this equation with respect to v, so d over dv of this, we can write it like this. U minus 1 is equal to d over dv f minus 1. Now derivative of this, power multiplied, then subtract 1 from the power, minus again here. So when you multiply power minus 1 in this, it become positive, subtract power, subtract 1 from the power, and it is du over dv is equal to, f is constant, so its derivative will be 0. I think you know how to differentiate this. So it is minus 1 upon v square plus 1 upon u square into du over dv is equal to 0. So if I move this on this side, so it is 1 upon u square du over dv is equal to 1 upon v square, right? Move v square on this side and dv over du on this side. So it is v square over u square is equal to dv over du, or dv over du is v square over u square. This is longitudinal magnification. So longitudinal magnification is v square over u square, or you can say square of transverse magnification. So this is relation between longitudinal magnification and transverse magnification. This is a relation.